So we'll go ahead and get started now. I'm with 2600 Hertz, and this presentation is about crossing language barriers for fun and profit. Kind of a example of what we did to improve a C node performance issue that we had. So who am I? My name is Karl Anderson. I'm one of the senior bit herders at 2600 Hertz. I don't have any real credentials that would wow this group, but I hope that you find this talk intriguing, interesting at least. So why am I giving this talk? We had an interesting problem with the C node implementation, and we came up with a fairly novel approach to correct it. And I think that it's something that at least warrants thought on your side, because it was something that we weren't used to. So when I say Kazoo and 2600 Hertz, how many people here have heard of those? And how, oh, wow. Okay. I was going to explain a little bit about it, but we'll go through it maybe a little quicker now. So Kazoo is, of course, our open source distributed communications platform. And a little while ago, it had a fairly significant problem. One of the core components, the FreeSWITCH, which handles all of our media, wasn't scaling the way that we anticipated that it would. By itself, FreeSWITCH scales extremely well and handles very large volumes. But every time we plugged into the existing mod Erlang event C node, we were reaching capacity rather quickly just because of the bottleneck in that connection. So, just real quick for, I think, the one of you who doesn't know what it is. What is Kazoo? This is a bit of an architectural diagram, or high-level diagram that you can see on our website. But in its simplest terms, it's a control layer focused around the telecom and communications problem domain. And right in the middle there, you can see the media servers, which we'll be talking about in just a moment. But the basic premise is you have your clients connecting via your mobile, your fax machines, your cell phones, your office phones into a cluster, which is broken up into zones. And then on the other side there, of course, you have your resources, things like carriers, E911 providers, taxation services. So for those of you who don't know what FreeSWITCH is, FreeSWITCH is a soft switch. It was written by one of the core contributors to the Asterisk library. When he proposed that they did a complete overhaul, they decided that they would part ways after that, and he went ahead and did it on his own and called it FreeSWITCH. It is architectured as follows, with a very strong and black box core that they maintain, and then the modules around it all plug into it with a very lightweight primitive interface. And the modules themselves all intercommunicate with an internal FreeSWITCH message bus. It's just key value pairs. Which makes it very natural to plug into something like Erlang. So what does mod Kazoo actually do? And or mod Erlang event in the earlier terms. So our application, we have something we call the eCall manager for the Erlang call manager. And its job is to connect into the FreeSWITCH servers themselves. And it is the low-level driver that actually translates an abstraction of, for instance, call logic into FreeSWITCH-specific terms. And it also maintains the state and information about the calls and where they are in which servers. And it also provides both load balancing and redundancy by interconnecting amongst all the FreeSWITCH servers. We've also used it as message buses to move internal states between FreeSWITCH servers. For things like channel recovery. When you want to move a call from one to the other, you can move that information to the other server and get it to pick up that call. So how does it work? This is the diagram of mod Erlang event. Mod Erlang event was already in FreeSWITCH's source tree when we came to it, and we decided to use it because it was a natural fit, of course, of tying Erlang into FreeSWITCH. It was originally written by Andrew, and the basic idea was you would connect to the C node via distributed Erlang using cookies and everything else just as if it was a regular Erlang node, and it would receive the data coming in on that socket in a loop that would then look to see if it was a command It would issue an execute to run that command. It would then look into an internal queue to see if any events that were coming through the FreeSWITCH internal bus had been queued up and waiting to go out that distributed socket. And if there were some, it would send them down the socket. Otherwise, it would loop back around and block. So what it looked like is this. I've stripped it out a little bit to make it a little clearer. But at the very top there, that EIX receive timeout is where it would actually block. One of the interesting things we tried to do originally was tweak that last number, which is how long to time out for, or the length of timeout, so that we could get down to the bottom here to send messages out quickly. But we found we would negatively impact things like the ticks, the heartbeats, which was an interesting finding. And we can go over a little bit about that in a minute. But we would try to receive a message off the socket. We get into these Erlang send switch commands, which would actually perform a blocking operation, thereby inhibiting the ability to send out events. Now that was an interesting side effect of the way that this was implemented, because there are some commands in FreeSWITCH that require you to participate in order for them to continue. So one example would be if you spin up a conference, FreeSWITCH will ask for the XML for how that conference should be configured. And that XML, of course, is intended to go down this pipe. But it's blocked on this handle message, which is where you're asked it to execute the conference. So you end up with this where you're blocking yourself condition, and because of the timeouts, you're not deadlocking, but it's pretty close. The way that Andrew had solved this is there was in addition to the API command to execute a command, there was a background API. And the background API would spin up a thread to handle just that command request, which is fine, but extremely expensive, especially the more work that you do. On very busy systems, you can clearly see why you don't want to be doing all those context switches and doing it that way. So there was no real easy way around this in this implementation. And the reason that it was kind of looked the way that it does is because it was really designed, or at least I would argue that it was designed for the other direction, where FreeSWITCH would ultimately take control of the call and then pass the authority of the call off to a Kazoo node, rather than the Kazoo node reaching in and stealing that call control from FreeSWITCH's internals. And you can also see it didn't really know what people would do with it, so there were things like check log queue, where you could actually send all the log lines out, which we never actually did in Mod Kazoo, but it was additional step and additional code that it had to go through, which required additional mutexes as well in order to get to this, because all of this shared a central state. And one of the funny stories when we first approached him and told him we were having a bit of an issue when we connected two eCall managers to one FreeSWITCH server, he was surprised it actually worked. So it wasn't exactly his intended use case. So we were running into all kinds of problems throughout the code just because we were trying to do something he hadn't actually anticipated. So there was an impedance mismatch there. So the other side of it is in Kazoo, we were writing Erlang that looked like something like this. This is actually directly from his example, freeswitch.erl module. And you can see not only it's Erlang, but it's not exactly OTP. It doesn't really provide a whole lot of guarantees or safeties on it. Additionally, things like the background API in this qualified send here with background common node, that actually means nothing. Originally, they all read foo. So the C node side was pretty much just the bare minimum to decode and the bare minimum to send back, and it was up to the application to resolve it. Additionally, some of the early implementations in this didn't even have these quantifiers on the tuple tags. So if you were in a gen server, all your messages might go missing all of a sudden, or a couple of the very important ones, which took us a bit of time to kind of figure out where those were going, because we were just calling into his library and never actually looked into it. So you can see not only are we issuing a background API, which is giving a thread on the other side, but we have to spawn here as well. So what was the problem with this? Well, it was less than stable. It stayed up most of the time. There were mutexes in there somewhere that kept stepping on the internal FreeSWITCH events that were causing FreeSWITCH to crash in very random places, which had us scratching our head as we went down all kinds of rabbit holes from the various core dumps. So The solution? Well, if plan A doesn't work, we still have 25 more letters in the alphabet. So let's just go ahead, and it wasn't originally built for mod Erlang event, wasn't originally built for Kazoo. So let's copy the file over, call it mod Kazoo, and rip out anything we don't need. Let's simplify it. Let's go through, find any place where we can take out mutexes, and let's kind of also go at it with the idea that we'll have more than one connection in there. So maybe there's some places that we can optimize some code so that we don't have to have this shared state, and those two guys can operate independently and separately. So that was our first stab at it. It was just a simplification of mod Erlang event. It helped, but it still had the impedance mismatch in that it still wasn't ever really designed for these multiple connections and these really rapid event streams going back and forth between the two. Because ultimately, we're still in that one socket, and the commands coming in are still backing up on the events going back out. One of the interesting things that we tried to do on version 2.0, I shouldn't have advanced so fast, was we tried to start up two threads, one to send and one to receive on the socket. Now, in principle, we should be able to do that, but because the Erlang interface library handles all the magic of the distributed Erlang behind the scenes, you can never really know whether or not it's actually going to respond to a tick and try to write to the file descriptor. So there were no guarantees unless you put a mutex around that, and there you've just blocked the other thread, so there wasn't any real benefit to that. So that was when we started to realize that there really wasn't a good way that we could just simply tweak this, that we needed a bigger hammer. So version 3.0 was when we actually sat down, took a look at it, and started bouncing some ideas around about how can we get more stuff down this pipe, how can we make this work better with mod Kazoo, and how can we drop, because the original mod Kazoo version 2.0 of mod Erlang event had actually maintained backwards compatibility for the inbound socket connections. And a lot of the APIs had, well, all this APIs had stayed the same. So what we started talking about, we started playing with the idea that, well, if we want to use distributed Erlang, then we can simply register various node names. So maybe we'll have FreeSWITCH underscore event at hostname, and we'll have FreeSWITCH underscore command at hostname. And here we can start to get a bunch of sockets, even though they're all fundamentally the same C node. EPMD doesn't know or care about that. So that was the first thought that we had. And then we started thinking, well, do we really need the distributed Erlang component? And the answer was yes, we needed that for the persistence, and we needed all the guarantees that it provides, the tick, the heartbeat, the link. But we didn't need that on the events. There was no reason to have that overhead on something that's simply a one-way mass stream of people answer calls, all kinds of internal FreeSWITCH events. So this is ultimately kind of what the architecture started to look like. We still build our C node, and we still connect a distributed Erlang socket to it. And that is represented by these top two guys, where you kind of have almost an RPC. Requests come in, and they're queued up. They go to a series of executors or workers, and then those responses are queued up and sent back down that pipe. Beneath that, however, is the new event streams that get spun up. And the event streams are independent threads, which are fed events from the FreeSWITCH event bindings, and they go down the socket completely separate from each other as well, which was an interesting, because now all of a sudden the events could come in a different order. Whereas before, they would stack up in order in the socket. Now we can actually receive them in a different order. So there, you have to give to get, and these were the trade-offs that we decided were perfectly viable. The other element, too, is there's a lot more sockets to maintain. And if you close off, say, channel answer, you get all kinds of weird things like calls hung up that you never even knew about. So you have to start to code differently on the other side as well to kind of take some of these caveats into account. So the other interesting thing that happened, and this was specifically to me, and I know a lot of people are going to say, well, that's just good code practice. That's probably true, but I had originally dabbled in C, and interestingly, had only done a bunch of picks up until that point. So, for me, when I started going back and looking at C after writing Erlang for something like 4 years solely up to that point, I started to see patterns, and of course, FreeSWITCH being an internal messaging bus with queues and all of those things already there, that translated quite nicely into Erlang terms. And trying to connect to it from Erlang, of course, didn't hurt. So I started to see things like this. So we can start mod Kazoo, which is our interface into the FreeSWITCH library. The main runtime thread opens the listener socket, registers with the EPMD. We can bind Kazoo fetch agents. Internally, FreeSWITCH, when it needs XML, it's not parallelized, and you have to do some fun stuff with mutexes there. But otherwise, the rest of these guys can be started almost as a supervisor. So of course, we don't have any crash guarantees or any restart capabilities here. But Kazoo node manages every incoming Kazoo socket, every incoming Kazoo node that is connected to the system, and then spins up in number of event streams underneath it in order to fulfill the need of whatever that Kazoo node is requesting. Which started to look a lot more like this. So this is the comparable code in mod Kazoo from the previous one, mod Erlang event. So the very first thing is right at the very top, we now have a queue of requests that need to go back down the distributed Erlang pipe. For instance, we could call that a mailbox. We, again, have our receive. Unfortunately, that's just the nature of the thing. But all of a sudden, we can drop that timeout to something slightly reasonable so we don't consume all the CPU if we get into a tight loop here. There's yields elsewhere, too, if we need to. But and then when we receive a message, we don't have to block anymore. We can push those into our workers' mailbox as well. So this starts to look a lot like a gen server pattern. And the more I got into this, the more I started to see that. And what was interesting is the things that it's passing around, these structures, I started to see that as my state. And when I started to see that as my state, I started to defend against other things accessing it without going through the mailboxes. And that started to give me all kinds of ways to remove mutexes and all kinds of other locking mechanisms as well. And again, you know, these kind of patterns, sure, you really should be seeing these things already. But coming again at it from an Erlang perspective, that's where I really learned to hone those patterns. And so coming back to the C code, I was able to apply them and start to make some progress with getting the system more efficient. Then, you know, while we're at it, let's go ahead and make the Kazoo side a lot more OTP friendly here. So this is what the new requests to the C node look like. Mod Kazoo is actually important. It's registered as it's the name, and we'll check for it on the other side, which also, interestingly, lets us expand into other places so we could have other name processes and things like that down the road, because we kind of namespaced ourselves a little bit there. And then the API remained fairly comparable as far as send event, run, execute some API command, because, of course, we're trying to do the same thing. And this is where that wrapped a bit, but this is the code that's responsible for the event streams, and obviously a very small snippet of it, but the important bit. We take out of our mailbox there the incoming event stream, and if we happen to have a socket, then we will encode it here with the EI commands right there for the encode switch event, and I'll show you that a little bit later on. We then take the high and the low, and we put those into a socket, and then we send down the Erlang. So effectively, what we're using the Erlang interface library for here is simply encoding Erlang terms and then pushing them down a raw TCP socket. Now, one of the important notes on the bottom here is that you do, for the next bit that I'll show you, need to enable TCP no delay. And that turns off the Nagel algorithm, which means that every time we do these switch socket sends, that is a packet. So the trade-off here is now all of a sudden we have 3 packets for every event. Granted, 2 are very small. They're also TCP packets. So we did pick up a bit of overhead there, but overall the efficiency is much, much, much higher. And there's, of course, room for improvement here. Now we have knobs we could tweak. These could be UDP streams and all kinds of other interesting things we could do. But on the other side, once again, still keeping with the OTP stream thought, this is now how we receive these event streams. So we open our IP port back to the awaiting listener that we commanded to establish itself via the distributed Erlang. Basically, the command is, I would like these events. It tells us I'm at this IP and port, and then we go ahead and connect to it. We expect it to come in as binary, and then that packet 2 is how those event streams are framed, which is where we saw the high-low order bytes going out first before the event actually went down the stream. So now we're picking up all the OTP guarantees, but none of the overhead from the distributed Erlang. So I'm not sure if any of you guys have actually gone and looked at writing your own C nodes. This experience, when I first approached it, I was fairly intimidated. It seemed like coming back to C after all that time, writing a C node to talk to Erlang, decoding Erlang terms and all that seemed pretty daunting at first. So just real quick, if you haven't actually looked into how to do this, it's remarkably easy. And the first thing that you have to do is run this EI connect X init. And although this is just telling EPMD, here I am, here's my name, here's my host, here's what I think my host is anyway. Doesn't actually have to be right. Step 2, you're actually going to wait for a Erlang node to connect to you. So there are many flavors of most of the commands in the library. They've done a pretty good job keeping them consistent. So anytime you see underscore TMO, that's with the timeout. And so there's an EI accept and an EI accept TMIO, or TMO. The library takes care of all the cookie and all the translation as well. If you're talking across different versions, there's a compatibility mode that you can engage. If you want to go from, like, if you compiled with R16 and you're talking to R14 or something like that. And then the last step is, of course, to communicate once those connections come in. So EIX receive message. X is simply the thread safe version of EI receive message. And this is how you unpack a Erlang term that comes down the pipe. It looks a lot more complicated than it actually is. It's just extremely verbose. So your Erlang terms, if you're familiar with the binary wire protocol, they always start with the version. And then they go with tags and arities and such, depending, those all vary depending on what's after that. So this just simply says decode the version, and this has a running index. So every time you do that operation, it just advances you past that point in the Erlang binary term. So we decode the version, then we look forward. This does not advance the actual index, but we look to see forward what's coming next. And if indeed it is, we expect a tuple in this particular case. And if indeed it is a tuple, we actually also picked up that size, which we'll use later. That's the arity of the tuple. We can decode that. We determine whether or not we got the arity that we wanted. And if you look at the comments, you can kind of see as it goes through, this is what we expect is a tuple of arity 3. Then we check to see if the first one is an atom, $gen call. Then we look at the next element. We expect the next element to be a nested tuple 2. And we expect a PID and a ref. We expect the last bit to be a request. And then eventually we get down here to we expect is underscore auth. So this is a gen call with a nested tuple in the second position with PID ref ending with is auth. Does anybody know what that is? No? So what that is netadmin ping. And what you would like to do when you receive a netadmin ping is put together a reply that says, yes, I am alive, and you were able to connect, hence pong. So we start a new buffer. We, again, start building this up with the Erlang binary version at the beginning of this buffer. We specify that following that will be a tuple of 2 elements. The first element is the reference that we extracted from the initial request, and the next one is yes. So we then send that down to the node, and the node now knows that we're alive, we're able to connect, and that the cookie is valid. So is this good for the company? Like I said before, when I started going back around and looking at these things, I started to see these guys to me as my internal state records. And when I started to look at that, again, I could start to protect these from being accessed from the outside world. The important note here, with the exception of the socket, which has the mutex, none of those actually have mutexes on them. And I chose this particular one specifically. Now, I know that I am glossing over some of the finer details. For instance, I am defining a queue, and the queue is an abstraction of APR, and that does indeed have mutexes internally to it. But the point being that this guy, once I start these up, I can't change them. So when you start, one of the decisions this led to is when you start an event stream, well, technically, I could very easily come back in and change that bindings and let you add and remove bindings from an active event stream. I very specifically disallowed that because now I don't need to lock any of this, right? So there are elements in here that led to like I say, the influence that Erlang had on me led to some of the design decisions because Kazoo had no need for that. I could then not provide that feature because I did actually code that at first. And when I started, like I say, when I started to look at these this different way, that's when I realized, well, if I remove that feature, I don't need that lock. If I don't need that lock, every single event that goes out doesn't have to lock its state. The next one, and this one again, that one wrapped too. Well, ignore the fact that that's a globals, but this is a pattern that I've been using quite a lot in Erlang. And obviously, again, it's just good coding, but the function decomposition has led me to use quite a lot of something like bind fetch agents that calls into bind fetch agent. A little bit confusing if you're not familiar or not looking for it. We also, in the office, have a habit of saying bind fetch agents to make sure that you know what we're talking about. But it translates quite well into C. I wrote very, very, very small functions, and I found that all of the functional decomposition that I was doing in Erlang, just to make very clean and take advantage of things like function pattern matching, actually translated really well into this, except it didn't pattern match. The other big one for me was, especially in FreeSWITCH. I don't know if you've ever looked through the FreeSWITCH source code. It's actually really, really good, but it's also very, very big. It's not uncommon to have files that exceed 10,000 lines of code. So when I went about writing mod Kazoo, after coming out of Erlang, writing a bunch of modules, each module has to be the same name as the file. You write a bunch of those files. I structured this the same way. And so what I did when I approached the problem is I thought about how would I write this in Erlang, and then I just translated Erlang into C without actually having written it. So that led to the file structure that you'll find in mod Kazoo now, which, while not amazing and complex, definitely led to much cleaner and very well-structured code because each one has a very clear responsibility. Well, I think so anyway. I can explain what that responsibility is if you didn't follow it. And if you can't read it, it says, here's where you made your mistake. Our mistake was trying to push everything down distributed Erlang, taking a library that was, of course, built to be a C node, and trying to jam our problem into that, and not really looking, well, I mean, sure, you don't want to bend things out of shape, but you can also use them in novel ways that are perfectly acceptable, like using the C node library in order to encode the terms, and using the distributed Erlang where it's important. So when you could take this library and use it for a lot more, well, at least you can use it to encode and decode, and not necessarily have to use it for just the C node component as well. So you could actually write a completely isolated and separate system and use the library to do all the decoding and encoding, although there might even be better options. But it was just something that I'd never really thought about before, that it was the C node library, and it would make a C node, and that would be one socket, and these were the mandates that had to be met. So this guy is one of the helper functions. It's just one of the last little things that we had to do. So on the end here, binaries don't come. I'm sorry, I had to remember which one this is because there's two of them. But binaries don't come in null terminated, and you have to do a little cleanup with like null extension, or you end up with some interesting crash dumps. And so there's a bit of cleanup that you can wrap the existing Erlang library around. Or other way around, so that you can handle those in an easier manner. And the other one is true here for the, this one is the function that takes the key value pairs that come in on the internal FreeSWITCH events and then map them into prop lists that then go out. Yeah, got that right. One of the interesting things there is, of course, you need to know how big it is before you send it, because you have to, in the Erlang, again, in the Erlang binary term, it's the version, what it is, and then how big is it. And you don't really know if you're doing it down here, so we have to loop over the list twice. Not a huge deal, but anyway, it was a little bit of a pain in the butt. And then this FreeSWITCH specific, I forgot about the body, and that was, oops. That does add a bit of space to it as well. So I have a habit of ending my slides very quickly. So I have a feeling there might be some questions here, though, with this particular audience. So I open the floor. I'll start with James.
Talk more, since you didn't mention it at all, about the filtering. I mean, that has
Yes, sorry.
efficiencies that we
Indeed.
didn't know.
Yeah, well, so I thought that would be a little too Kazoo specific. I was trying to keep it more C-node or general. But one of the efficiencies that we gained is internally in FreeSWITCH, it has a massive key value pair list. It's pretty much everything you ever wanted to know about the call, and anything that's ever touched it has added to that. So it gets quite big, and you can imagine most calls have UUIDs, and that UUID is then replicated umpteenth times in that particular payload, and domain names can get quite big, IPv6 headers. The point being, one of the efficiencies that we found was Kazoo doesn't need all of that information. So before we send it down the event stream, we actually pass it through a filter that removes, well, we only collect the headers that Kazoo is actually interested in sending down. And of course, that made a huge improvement in the overall bandwidth, as well as the processing load on the other sides. So the other component of that is, because this is pretty much a Kazoo, if you were to take this mod Kazoo, which of course doesn't have to connect to Kazoo, it's just called mod Kazoo, so you can connect any Erlang to it, and you can look at freeswitch.erl in our project, and you'll see it's just in server call, and you can see the API. But it's very similar to the previous API, so if you're familiar with that, it should almost work as a direct plugin, mostly. The events, though, will be filtered, and you can specify that filter in the configuration, the XML configuration. One of the upcoming, while we're on that topic, one of the upcoming optimizations that I hope to make is we also bind for certain event types, which is the most granular that you can within FreeSWITCH. So for instance, I can say I want all channel answer. But I can't say, a better example, I want all channel execute. But I can't say I want channel execute for conference and bridge and something else, because there's a lot of channel executes. And within Kazoo, we need channel execute to know when a fax starts and when a conference starts, but not for anything else. And you get one every time you issue a command or set a variable. So that's a lot of overhead just to fulfill those two needs. Now, unfortunately, up until recently, there wasn't a good way around that. So as a matter of fact, Luis here has probably already fixed the issue with the fax, so that one's done. And we publish conference participant events. So there's a very high probability we'll be able to remove channel execute completely from our message bus, which will significantly reduce. It'll half per call the messages on that bus. The other big improvement that I hope to make, and one of the ones that was very helpful for Kazoo's performance, was the fetch handler that I kind of glossed over, because again, that was very specific to Kazoo. That one is FreeSWITCH will request configuration XML, and it does that in a blocking manner internally in FreeSWITCH. And then, of course, we have to do that asynchronously on the distributed Erlang message. But well, we don't have to, but we do. Before, it would go to both or multiple connected eCall managers, right, which would block, which would significantly block the previous versions. But it was also result in 2 requests to process that call, so lots of hits to the database. Those messages now round robin, and they have, well, since 2 point something. The next element that I want to add is an event binding that you can build that will round robin the events that are bound to it. So for example, channel answer, create, and destroy are right now duplicated because all events go to all connected Kazoo, well, if they asked for it, which we do. But those 3 events in particular would be very useful to singlify, quote unquote, and the best place to singlify or to dedupe those would be at the FreeSWITCH level, because we can do failure recovery there, and that's where the call is. So if the call goes down and the FreeSWITCH goes down where we're deduping it, it doesn't matter because we can't control it anyway. So that would be the next big optimization. So as far as filters and features go, that's where we're going with that. Are there other questions? Yeah.
So we use mod Erlang. And I'm curious, at what kind of scale did you start noticing problems with it, and what were the symptoms you saw so that you started?
Yeah, no problem. Just out of curiosity, are you doing inbound or outbound? So your dial plane hands-off control, or do you have a connected socket?
We are using it much more. We're using it much more at subscriber conference events. So we're pretty. We're not using it in that plan at all. And it's just both directions. So we're receiving all the conference events and then sending some things back.
I got you. Absolutely. So I don't suspect you'll have an issue, well, or at least not a significant one, because you would have known it by now for sure. Our issue was it would crash FreeSWITCH servers pretty regularly. So, and like I say, the core dumps that we got, we never actually truly found the final place. We got the number of crashes down to a low count. But in a clustered environment, it's dropping calls, which sucks. But at least the cluster was up. But the crash dumps seemed to indicate that it wasn't necessarily crashing in the mod Erlang event, but mod Erlang event was blocking, because when you bind into those event streams internally in FreeSWITCH, you actually are serially bound with all the other event stream guys. And we figured that it was either stopping on it, or it was blocking for a longer operation than another module expected. And so those events would then come in later, trigger some thing over in mod Sophia, because it kept moving. It was over in mod Sophia, and then it moved over to a playback, and then it was up over here. So that was what you would see. So.
So same question, kind of follow-up question. So I also use the mod Erlang event. So I'm just curious, the config file events, and that's going to be on the FreeSWITCH box itself?
I'm sorry, the what is?
The config file is going to be on the FreeSWITCH box or on your application side?
Which config file? The config file for?
The one for subscription.
So that is actually, I'm sorry, the subscriptions are done when you connect through the distributed Erlang, you make the request, so it's an API. And so you would connect your Erlang, whatever, to the C node, and you would say, hey, I want channel answer events, and the reply that you get back as a gen call is going to be the IP and port that you connect to. And so you can dynamically create any events.
You have tweaked all the FreeSWITCH.org file, I guess, right? So you have made all these changes into the FreeSWITCH.org, the way the new API will work?
Right, yeah, exactly. And our FreeSWITCH.org is the derivative of the original, so it's similar, but internally it's completely refactored. And I think, like I say, there's no reason you need it. It was obviously originally also just the example that everyone used. So you can actually just do gen server calls directly from wherever you want. It's got all the same OTP interfaces that you would normally have. Does that make sense?
Because I also use it heavily. I don't even know problem is with my mod Erlang event yet. There might be problems. I don't even know. So I will try this also.
Yeah, please do. Now, I will say, this is currently on our repo listed here, GitHub 26. You'll find a whole bunch of repos there for the Kazoo project. It's got lots of components, well, several components. You can pull mod Kazoo directly out of this, just the folder, and drop it in a native vanilla FreeSWITCH. The only thing I think is missing in a native FreeSWITCH is they use APR, the Apache Portability Runtime Library, and there's one function they didn't wrap and expose, and it's a direct expose. So it's just, I think it's the OS socket put or OS socket get. One of them is not in there. But it should have gone upstream, and this is intended to go upstream. So let me also tell you, all of this and our entire repo was originally just a temporary dev place. And we have met with them several times. And as a matter of fact, our very own Darren Schreiber has commit access. And we keep thinking, or we keep threatening to commit this back upstream, and they say, please do. And then we find, oh, that one patch really can't go upstream until we wrap it in a config option, because that'll just damage everybody up, in the other not using mod Kazoo. And then we'll do that a little later. We'll do that a little later. So there's nothing here that's dangerous or will break FreeSWITCH. This is all. The only changes to our FreeSWITCH, just so you're aware, is we've added additional events. And we've written mod Kazoo. We wrote another one called mod channel move, but they're completely isolated. So all of that can be pulled into a native or a vanilla FreeSWITCH if you wanted to compile natively. We also have the latest stable 1.42, which depending on what version you're running. So you might be able just to pull it down. And that's mangled slightly in that it's got our changes on it. So you'll get a lot more events for when you do set and export. But otherwise, it'll work just fine. No code is removed, just more events internally. Good. Any other questions, comments, concerns? All right. I appreciate it, guys.